Okay, today we're going to do our 4 doodle notes on changes in state. So on our sheet of paper we're going to go ahead and label what notes these are. And these are on changes in state. Okay, these notes are not going to be very long, so we're going to get through this pretty quickly. First thing that's really important to know is the difference between thermal energy and temperature. So we're going to do thermal energy versus temperature. And we're going to remember that thermal energy is the total energy. Okay, so this is counting the total motion of the molecules. And then temperature is the average speed of the molecules. Okay, so in this side we're just counting, sorry, get a lightsaber out for this one. Okay, so in this one we're just counting total energy, and in this one we're counting average speed. Okay, so temperature is average, thermal is total. So if we were to have an example of this, if we have a swimming pool, and we have a cup of water. Okay, the cup of water has a temperature of 212 degrees Fahrenheit, which is water's boiling point, and the swimming pool is 45 degrees Fahrenheit. Even though the cup of water has a higher temperature, the swimming pool still has more thermal energy because it has more molecules. Sorry, I wrote molecules when I meant thermal energy. I got ahead of myself there. Thermal energy because it has more molecules. Okay, that's the top half of your page. So down at the bottom half, we're going to do a phase change triangle. So it's kind of really important to understand how this works. We're going to start with a solid, and this is just the whole bottom half of your page. So you can make this pretty big. And then you have a liquid, and then you have a gas. Okay. So if we're going to gain energy and go from a liquid, if we're going to lose energy and go from a liquid to a solid, we call that freezing, because we have to lose energy in order to get colder. Have to take energy away in order to freeze into a solid. If we're going to increase energy from a solid to a liquid, we call that melting. Now, if we're going to increase energy from a liquid to a gas, we're going to call that vaporizing. And we're going to remember that there are 2 parts to vaporizing. There's evaporation and there's boiling. And boiling happens throughout the substance. That's why you have bubbles at the bottom of the pot, because that's evaporated water. And evaporation happens only on the surface. Now, if we're going to cool a gas back to a liquid, we call that condensation. Now, if we're going to cool a gas to a solid, this is a term we don't really need to know for our SOL, but a lot of kids want to know what this is. And we call that deposition. It's where a gas gets frozen straight down into a solid without passing a liquid phase. I'm going to try and write this a little bit better. And then if we're going from a solid and we're going to increase so much energy that it goes directly into a gas state without passing the liquid phase, we're going to call that sublimation. And that's how we make our change in state triangle. It's really good to practice this in hopes that you might be able to recreate this on your own. So freezing is going to be like ice. Melting is going to be melting ice into liquid. Condensation happens on your glass. Vaporization can happen on your stove, or it can happen with a water puddle. Deposition is when you're making dry ice. So you're taking carbon dioxide, because dry ice is made out of carbon dioxide, and it goes into a solid. And then sublimation is when you turn dry ice will go back into a gas, or mothballs that we use to preserve clothing, or those air fragrance gels that we might use in our cars or in our bathrooms, where they go straight from a gel solid to a gas that you smell in your air without passing the liquid stage and making a mess.